Welcome, guys. Last two sessions, we spoke about queue implementation in C++, and also we spoke theoretically what are the operations can be done on queue, and also we discussed the time complexity of each operation, like Enqueue, Dequeue, front, rear, and size and IsEmpty kind of functionalities. Okay. As part of this session, we'll talk about and we'll implement a queue using Golang. Okay. So yeah, what we can do is we can create a package main, and I want to make the some const of size, max size of, and queue is 100. Okay, max size of queue. Okay, perfect. So what we will do, we'll create a one struct actually of type queue, right, and which will have front of type integer. This is actually index of the front element in the queue, and second thing is rare integer of type integer, index of the rare element in the queue, right, and we'll create an array to store the queue element of size, max size, whatever we declared const actually of type integer only. This is actually array to hold the queue elements. Okay, perfect. So we declared the queue with the required fields, right? So what we will do is we'll try to implement the first. I'm planning to implement the empty method. Okay, check is empty or not. Empty or not. Check is queue is empty or not. Okay, or not. This is actually of one time complexity only. It will take. I will explain why it is taking. What I will do is func queue queue is empty. It will return boolean variable. Okay, so what we will do is q dot front equal to -1. That's it. Okay, this I need for helper function, that's why I implemented first. Actually I will implement one more helper function for is q is full or not, because we are making some fixed size, right? That let's do it. uh, checks checking is the queue is full or not. This also like of one time complexity only. Okay, so now func q star q uh, is full. Now just return q dot rare equal to max size -1. That's it. Okay, now we will see the real operations of like in q and all. So we'll see that uh, basically we spoke, right? What is in queue? Actually we are trying to insert an element from the rare. Okay, add element at rare, and this also will take WAF one time complexity, and we'll see that implementation now. Func q star q, and it will take of data of type integer, right? Okay. Now what we will do is we'll try to check if q dot is full. What if this q is full? We can't do anything here, right? IsEmpty dot println q is full. You can't insert any element because we already inserted 100 elements. I mean q already has 100 elements here. Okay, I mean max size. Also you check q dot is empty. If this is the case, then q dot front we need to set to 0. This is basically first time actually we are first element we are trying to insert. Q dot rare plus plus. Oops. Now q dot array of q dot rare equal to element. Sorry, data. So by default actually this will be, we will initialize with -1, so it will become 0 once we do this operation here. Okay, so this one if you see, observe that this will be nothing we are doing, we are just trying to go to that rare position, we are just adding the data value to that particular position in an array. So this will be of one time complexity only. Next thing is actually dequeue. What dequeue will do, remove element at at front. This also will take of one time complexity only. Okay, 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 let us see this func q store of q. It takes nothing, no parameter, nothing. So what we will do is if if q is empty, you can't do anything here, right? Q is empty, you can't delete any element from the rare. Else, also you need to check if q dot front equal to q dot rare. If this is the case, then q dot front equal to -1 and q dot rare equal to -1. What it means is this became empty basically. Okay. Else you need to do q dot front plus plus. You're just changing the position uh, from the front. That's it. Okay. Next operation will be get an element from the front and rear, right? Func q star q front. Basically, this will return the value of integer actually. So here what we can do is if q dot is empty, again you can't do much here. uh, q is empty, q is empty, and you can return -1 here. Okay, else this is also front also just one time complexity actually of one basically. Q dot array of q dot front, that's it. So element front of the queue and its time complexity is of 1 because you are tracking that index right using front, so only one operation of 1. So get an element from the rear, and this also will be taking of 1 time complexity. Okay, func q star q rare, and it will return integer. Oops. Okay, here again you can check if q dot is empty, then fmt dot println q is empty. Return -1. Otherwise, just return array of q dot rare. This is also of one time complete because we are not doing any loops or anything. Just going to array and the rare position we are just returning, right? So for me, I want to display. I will write the display method also. Display as well. Func q q display. Okay. Again, you will check q dot is empty. Just we are checking like q is empty or not. Println q is q is empty, and just return from here. Nothing to print actually. If q has some values, then what we need to do? We need to start from the front. Q dot oops front less than or equal to q dot rare I plus plus fmt dot print percentage of d q dot arr of I. Okay, we'll give some space here so that we can be readable. Okay, once we print everything, we'll try to give one new line here. Fmt dot println. That's it about all operations, and also we spoke about its time complexities. Now let us write our main method. Func main. Now what we will do is we'll try to create a queue object oops, queue front will be -1, comma rear also -1. Initially we'll initialize with these values with -1, -1, right? Now we try to do enqueue of 1, queue dot enqueue of 2, queue dot enqueue of 3. Okay, let us display these three values and let us see. Expectation here is that it should print 1, 2, 3, right? Let us see that will work or not here. Run main.go. Perfect. We're able to print the values. Next operation, what we will do is we'll try to do the dequeue. Q dot dequeue and q dot display. So actual dequeue will delete element from the front, right? So the expected output will be here 2 and 3. Let us see that will work or not here as per our expectation. Perfect. So it is printing as per our expectation. Now let us see. Let us test println q dot front. Okay. Okay, front will be now it is 2, right? It's expected will be 2 by now. Let us see. Also, we'll check once again q dot rear also. Here it should print 3. Okay. Let us do that. Let us test that one. Perfect. So you can see the 2 in the front and the rear will be 3. Also dequeue the q dot dequeue q dot dequeue to just check the empty will be printing or not. Oops. Here we are expecting queue is empty. Let us run and check this one. Okay. Yeah. Cool. That's all about all these things. As part of this session, we covered uh, queue implementation using Golang and also all operations and its time complexity. Also, we verified all the operations on the queue from the main function, right? That's it about this queue operations using C++ and Golang, and you can check it out in previous sessions about C++ and theoretical discussion about the